2.3, fatigue and recovery. So I'm now going to be looking at recovery. Recovery is the action or process taken to return to a normal state of health, mind and strength. Recovery is very dependent on the sporting activity just performed, for instance, the duration and the intensity of the event, as well as the fuels and energy systems used. In addition, the waste products that are produced and how the body chooses to deal with them. During events that are higher intensity and shorter duration, like the shot put event and the 100-meter sprint, whereby the ATP and P systems are depleted, the aerobic system uses oxygen to produce energy to resynthesize ATP by sticking the P back on, using waste products of ADP and a single phosphate, as well as rejoining phosphate and creatine and more stores. This process uses about 3 to 4 litres of oxygen. The process is very quick, which is beneficial for events such as shot put, as they're able to replenish their stores completely and perform at maximal, and then they're able to perform maximally each throw. So looking at the epoch graph, and in particular the fast component of epoch, which is the lactic fast recovery, which is labelled A. Epoch is smaller due to the fact there is a faster recovery. During this phase, more VO2 is consumed and resaturated to resaturate myoglobin and hemoglobin with oxygen. The myoglobin joins with the oxygen so that oxygen can be transported to the mitochondria, where exercise occurs again. This roughly takes half a litre of oxygen to become 100% recovered. In addition, during this stage, ATP and PC stores are resynthesized. This process takes around 3 minutes for stores to become 100% recovered. So now looking at moderate intensity and moderate duration. For events that use more energy systems, such as the 400 and the 800 metre races, whereby the lactic acid system is used and therefore lactic acid is produced, the process of recovery is longer due to the build-up of lactic acid and hydrogen ions left in the blood. The build-up of lactic acid needs to be removed, and this can be done in 4 ways. So 65% of lactic acid is converted into pyruvate, which then enters the Krebs cycle and then can be converted to carbon dioxide and water. 5% of lactic acid is converted into glucose. 20% of the lactic acid is converted into glycogen and is entered into the Cori cycle. Lactate is taken to the liver and then transferred into pyruvate, which is what the Cori cycle is, and 10% is converted into protein. For events such as the 400 metre, there will be a large oxygen deficit and therefore a large epoch due to the exercise being anaerobic. To recover from this type of activity, both components of epoch are used. However, mainly the slow component, which is lactacid. This helps to remove lactic acid by oxidizing it, as well as helps to remove carbon dioxide. In addition, it helps and allows the replenishment of glycogen stores. However, this can take up to 2 hours. DOMS, which is the delayed onset of muscle soreness, can occur as a result of exercise at moderate intensity and duration. It is caused by myofibril tears. It can cause pain and swelling 48 hours post-exercise. To reduce DOM, passive stretching and foam rollers can be used to help remove knots and reduce pain after. So, submaximal intensity and long duration recovery. Recovery for exercises which are low intensity and long duration can be quick and is a lot quicker than maximal exercise, as shown by the graph. This is due to less VO2 being consumed. From the graph, which shows typical values and amounts for this type of exercise, you can see that there is a smaller oxygen deficit. This is due to the fact oxygen is used when using the aerobic system. This in turn means it's a small epoch due to there being less oxygen to pay back as oxygen is being used throughout. The recovery is also quicker than before due to there being less lactic acid, as the main energy system used is the aerobic system. Therefore, the main waste products is carbon dioxide, which can be removed by lactate slow recovery, and in particular can be removed in 3 ways. So the majority of CO2 is removed. Around 70% is carried in the plasma as carbonic acid, which can then combine with H2O. 23% is carried by hemoglobin as carbon hemoglobin, and 7% is dissolved in plasma. After events such as a marathon, glycogen stores need to be replenished. This, however, can take days, and therefore the lactic fast recovery is used to help saturate myoglobin and hemoglobin again. So finally, looking at intermittent activity recovery. During gameplay, such as football, recovery is able to happen within the game, which can be beneficial to the players as it means they're able to resynthesize ATP and make PC stores, which they can then use again. From the graph, you can see how the different energy system stores and how they are used over a period of time. Glucose is important